Hi, welcome to our math. Today I'm doing a series of videos on parabolas and graphing parabolas in vertex form. In this video, what I want to do is I want to focus on how this h affects the graph. I'm going to start by graphing just y equals x squared, the most basic version of a parabola. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So I do a negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and then I'm going to connect these dots in a smooth, continuous curve. And there is my most basic of parabolas. Next, what I'm going to do is I'm going to graph y equals x minus 5 squared. Now, if you notice my inputs have been adjusted, the reason they've been adjusted is because if I put 5 in here, 5 minus 5 is 0 and 0 squared is 0. I like having that 0 in the middle. Let's see, 3 minus 5 squared is negative 2, negative 2 squared is 4, 4 minus 5 squared is negative 1, negative 1 squared is 1, 6 minus 5 is 1 squared is 1, 7 minus 5 is 2, 2 squared is 4. So I have 3, 4, 1, 2, 3, 1, 2, 3, 4, 4, 1, 5, 0, 6, 1, 7, 4, and here we go. I have my smooth, continuous parabola. All right, my next graph that I'm going to graph is going to be y equals negative x plus 3 squared. If I put in a negative 5 plus 3 is negative 2. Negative 2 squared is 4, but then there's that extra negative, so this becomes a negative 4. Negative 4 plus 3 is negative 1. Negative 1 squared is 1, but then there's an extra negative, so this is a negative 1. Negative 3 plus 3 is 0. 0 squared is 0. Negative 2 plus 3 is 1, 1 squared is 1, but there's that negative. Negative 1 plus 3 is 2, 2 squared is 4, but there's that negative. So we have negative 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 4, negative 1. Negative 3, 0. Negative 2, negative 1. And negative 1, negative 4. Connect the dots with a smooth, continuous curve. Okay, now I'm going to have to come back and fill in a few pieces I didn't do the first time. The domain of all of these is all real. The reason the domain for all three is all real is because what we're doing is we're taking an input, maybe adding or subtracting, but ultimately we're taking a number and squaring it. And you can square any number. There's no restriction on squaring, and that's what a domain really is we're looking for a restriction. The range, our restriction on y is on this one, is y starts at 0 and goes up, goes positive. So our range is 0 to infinity. I have a bracket here because it's included. This is like y is greater than or equal to 0 because that 0 is included because that point is actually there. For the next one, my range is also 0 to infinity because though the parabola shifted over, the smallest value, the smallest y value is still 0. For my last one, if we notice, it's pointing down, which means it's not going to positive infinity, it's going to negative infinity. But it still goes all the way up to 0 before turning around and going back to negative infinity. Okay, so let's look at these questions down here. It says, I have a reminder of what the equation is, and we're asked, what is h in each of the graphs? Well, in the first one, the number in the parentheses squared was 0. There was no number there. In the second one, remember it's x minus h, and we had x minus 5, which means h is 5. And in our last one, we have x plus 3, which means h is a negative 3. All right, if we look at the graphs, and how h affects it, h is a left-right shift. Because if we look at all of our graphs, it shifted left and right. This one pointed down because the a out in front was negative, which you can see another video about a to see how that a made it negative. but when h was 5, we moved to plus 5. And when h was -3, we moved back to -3. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you in the next video. Thanks.